Section 4.4, Contingency Tables and Association. In this section, we're going to compute the marginal distribution of a variable, construct a conditional distribution of a variable, and then use the conditional distribution to identify association between categorical data. Sections 4.1 to 4.3 dealt with looking at relationships between two what kind of variables. They were quantitative variables. We also know how to compare the relation between a quantitative variable and a qualitative variable. We can do that with side-by-side box plots. Now we're going to describe relationships between two qualitative variables. So here's an example. Now a professor at a community college in New Mexico conducted a study to assess the effectiveness of delivering an introductory statistics course via traditional lecture-based method, online delivery, which is no classroom instruction, and then a hybrid instruction, which is an online course with weekly meetings methods. And the grades students received in each of the course were tallied. Now, the table is referred to as a contingency table or a two-way table because it relates two categories of data. We have the row variable, which is the grade, because each row in a table describes the grade received for each group. Okay, and then we have the column variable, which is the delivery method, meaning traditional, online, and hybrid. And now each box inside a table is referred to as a cell. Now, so this data basically shows a relationship between two qualitative variables. One of the variables is the delivery method, and the other variable is the letter grade. And so both are clearly qualitative variables. We organize the data in something called, again, a contingency or two-way table. Again, we have a row table or a row variable. And our row variable, again, in this particular example, is a grade because there are rows. And then we have a column variable, which again represents the delivery method. Now, each of the tallies within the intersection of a row and column represents a cell. So we're going to be, and now again, the cell, okay, so it said, again, the intersection of the row and cell are all of these values here. So these are considered the cell. Okay, now we're going to be doing this exact same thing with this type of data that we did with comparing two quantitative variables. We want to see if we can determine if there's any kind of association or relationship amongst the variables. And so the question becomes, well, how do I come up with any kind of numerical or graphical descriptions of this data so that I can get a message across? So, starting with objective 1. We want to compute the marginal distribution of a variable. The first step in summarizing data in a contingency table is to determine the distribution of each variable separately. To do so, we create marginal distributions. A marginal distribution of a variable is a frequency or relative frequency distribution of either the row or column variable in the contingency table. A marginal distribution removes the effect of either the row variable or the column variable in the contingency table. To create a marginal distribution for a variable, we're going to calculate the row and column totals for each category of the variable. The row totals represent the distribution of the row variable, and the column totals represent the distribution of the column variable. Okay, so let's take a look at the row. Okay, so here we have level of education, we have employment status, we have did not finish high school graduate, some college, and then bachelor's degree or higher. And so each row is represented by employed, unemployed, and not in the labor force. Now, we're going to find the row total for the category employed. So if we're looking at the category employed, okay, we're going to add the number of employed individuals who do not finish high school, who graduated from high school, and so on. So we're going to add these four together, okay? And so then we're going to get this last column that represents the frequency marginal distribution for employment status. So we're going to take each one of these values, and then when we add them together, it's going to give us a total of 133,583 for the first row, which represents the employed, okay? So again, here we can see that. Now we're going to repeat the process for each category of the employment status. So now what we're going to do is we're going to move on to the next category for the row, and it's unemployed. So we're going to add up each value, did not finish high school graduate, some college, and bachelor's degree. So again, we're going to take our 628 plus 1697 plus 1492 plus 1278. When we add that together, it gives us 5,095. Okay, and then we're going to do the same thing with the last row. So the last row is the not in labor force, and we're going to add these values, 4 values. So we're going to add those 4 together to get a total of 77,840. Okay, and so now what we're going to do is now we're going to find the column total for the category. So here's the category, did not finish high school. And so what we're going to do is we're going to add the column values. So we're going to add the employed, the unemployed, and the not in labor force. So let's go ahead and do that. So we're going to add this together, and this together. Okay, and so what does that do? Well, again, the title of this is the frequency marginal distribution for the level of education. So we're going to add 9,671, 628, and 12,564. And again, that total is going to give us 22,863. Okay, likewise, we're going to look at the column for high school graduates. Okay, and we're going to add up these values. So again, for high school graduates, we're going to add up these values. So we get 34,211, 1,697, plus 26,406. And so that gives us a total of 62,314. Next, we're going to add the next column, some college. So we're going to add these 3 values together. When we add them together, then we get a total of 56,779. Okay, and then the last column is the bachelor's degree or higher, so we're going to add these values together. So when we add those values together, then it gives us this following. Okay, now let's add these numbers together and see what we get on our calculator. Okay. So let's add these numbers. So we have 133,583 plus 5,095 plus 77,840. Okay, so that gives us 216,518. Okay, now let's add the rows together. So we got 22,863 plus 62,314 plus 56,779 plus 74,562. When we add that, we get the exact same amount that we got when we added the columns. So that means that when we look at these values here, okay, when we add the total for both of them, we would get 216,518. So again, in the table, we can see that the green entries represented the marginal distribution of the row variables, the employment status, and again, we added the first row, all the values in the first row to get a total. Okay, and then the red entries were the row, so we were able to add all the column variables to get the level of education. Now, the marginal distribution for employment status removes the effect of level education, and the marginal distribution for level of education removes the effect of employment status. Now, the marginal distribution of level of education shows that there were more than 3 times as many civilian residents with a bachelor's degree or higher as there were Americans who did not finish high school. Meaning here we can see that for the bachelor's degree or higher, we had 74,562. And then for did not finish high school, we have 22,863. Now, the marginal distribution of the employment status shows that 5,095 Americans were unemployed, because this represents unemployed. Now, the table also indicates that there were 216,518 civilian non-institutional residents 25 years or older. Okay, now our next example is to determining the relative frequency marginal distributions. And so we're going to determine and interpret the relative frequency marginal distribution for the level of education and employment status from the data in Table 9. So these all numbers remain the same. Okay, and so what we want to do is the relative frequency marginal distribution for the row variable employment status is found by dividing the row total for each employment status by the table total, which is 216,518. So the relative frequency marginal distribution for the column variable, the level of education, is again found by dividing the column total for each level of education and then dividing it by the table total. So let's take a look at these values. So 133,583 was the total when we added up everything in that first row. So let's go ahead and look at that value. So when we add up these total values, this was the total. And then what we did is we divided it by the table total, which was 216,518. So when we divided those two values, then we get a relative frequency of 0.617. Again, we're going to take 628, 1697, 1492, 1278, which gave us 5,095. And then we're dividing it by the total, the table total. And again, that gives us a total of relative frequency of 0.024. Likewise, we're going to take these values that are all in the row and we added that to get the numerator, and we're going to divide it by the table total. And again, what that gives us is a relative frequency of 0.360. So when we add these three values together, it should give us a total of 1. Let's go ahead and check that to make sure that we're good here. So if we take 0.617 plus 0.024 plus 0.360, then that gives us a total of 1. Now, it's approximate, which is 1.001, but it gives us a total of 1. Okay, now what we're going to do is now we're going to add up the columns and then divide it by the total. So if we take the columns, okay, so if we add up this value, and this value, that's going to give us our total. And then we're going to divide it by the table total, which then gives us a relative frequency of 0.106. Okay, next, we're going to take this three values in the column, and that's our numerator, and then we're going to divide it by the total to then get a relative frequency of 0.288. Okay, next, we're going to take these values here to get the total, and then divide it by the table total of 216,518 to get 0.262. And then the last, we're going to do the following. We're going to take these three values to get 74,562 and then divide it by the table total to then get a total of 0.344. Now again, when we add all those up, we should also get 1. So let's go ahead and add those up. So 0.106 plus 0.288 plus 0.262 plus the last one is 0.344, and that gives us 1. Okay, so therefore that gives us 1 here. Now again, the table above represents the relative frequency marginal distribution for each variable. So from the table, 10.6% of civilian, non-institutional residents 25 years old and older did not graduate from high school. Because if you look here, this 0.106, if we convert that to a decimal, to a percentage, you'd move that place to the right twice to give us 10.6. Okay, and then 61.7, which would be the employed status here. So 61.67% of civilian, non-institutional residents 25 years and older were employed in May 2017.